Hello students, today we are going to start our next chapter, gravitation. Basically this is the first part of gravitation in which we will study about what is gravitation and universal law of gravitation. But before going in detail with this part, let me tell you about Sir Isaac Newton. So Newton is generally regarded as the most original and influential theoretical physicist in the history of science. He was born in a farming family of Woolsthorpe, England. Then he was sent to study at Cambridge University. But during his study, what happened? A plague broke out in Cambridge in 1665 AD. And due to that, Newton took a year off from his studies. Some important contribution of Newton is that he discovered the law of gravitation, formulated the well-known laws of motion as we have learned in our previous chapter, and also worked on theories of light. So students, as I have already told you that Newton took a year off from his studies because of the sudden outbreak of plague in Cambridge University. And during that period, an incident happened with Newton. So what is that incident? One day Newton was sitting under an apple tree in his farmhouse and an apple fell on him. Now Newton started thinking about the cause of fall of apple. So first let me explain you the motion of the apple. So here you can see that when the apple starts falling towards the earth, then what happened? Its velocity is increasing. Or in other words, we can say the velocity is going to change. And if velocity is changing, then it means there must be an acceleration because acceleration is the rate of change of velocity. Hence we can say in the motion of the apple when it falls towards the earth, there is an acceleration. But again that acceleration is produced only because of a force. Hence we can say there must be a force due to which the apple starts falling towards the earth. Thus Newton concluded that the fall of the apple or any other object falling towards the earth due to the large force of attraction of the earth. It means that every object attracted toward the earth because of the force of attraction of earth. But again there arises a doubt that if there is force of attraction of earth everywhere, then why the moon continue to revolve around the earth and never fall on the earth? So in order to explain the motion of moon around the earth, let me recall you a concept of uniform circular motion that we have learned in the first chapter, motion. Now students, you know that motion of an object along a circular path with uniform speed is known as uniform circular motion. Let us take an activity in order to understand uniform circular motion. So here in this activity, you can see that a boy is whirling a stone with the help of a thread above his head in a horizontal circle with constant speed. Now let us take different positions of the stone in order to understand. So here we have the following positions A, B and C. Now let me tell you what will be the direction of motion at these points. If I ask you the direction of motion at the point A, then you can see the direction of motion at the point A is along the tangent at this point A. In the same way, the direction of motion at the point B and C is also along the tangent. Okay? It means that in the uniform circular motion, at every point the direction of motion is going to change. Now students, velocity is determined by two factors. First, speed and second, direction. So here in this uniform circular motion, you can see that the speed of the motion is constant, but the direction of motion is continuously changing. And due to change in direction of motion, we can say the velocity is changing. And if velocity is changing, it means there must be an acceleration because acceleration is the rate of change of velocity. Hence, we can conclude that in uniform circular motion, there is an acceleration. That's why it is known as accelerated motion. But if there is acceleration, then what is the force which is responsible for this acceleration? Hence, the force which is responsible for this acceleration is known as centripetal force. Centripetal force means center seeking force. Now here you can see the force which is responsible for producing acceleration in uniform circular motion is always acting towards the center along the radius. So here this is the force, and this force is known as centripetal force. So we can say that centripetal force is responsible for uniform circular motion. In the same way, Newton concluded that the motion of moon around the earth is due to the centripetal force. But again, from where does this centripetal force come? What is the source of the centripetal force due to which the moon revolves around the earth? So students, tell me, does the moon revolve in a nearly circular orbit if earth is not there? So obviously the answer is no. It means here the centripetal force is provided by the force of attraction of the earth. Hence we can say again, this is the force of attraction due to which the moon is able to revolve in a nearly circular orbit around the earth. So considering all these examples like falling of apple or any other object towards the earth, motion of planets around the sun, motion of moon around the earth, Newton come to a conclusion that all the objects in the universe attract each other, and the force of attraction is called gravitational force. It means in this universe there is a force of attraction between every two objects, and that force of attraction is called gravitational force. In simple words, we can define the gravitational force as the force of attraction between any two objects in the universe. So students, I hope it is clear that what is the gravitational force. So students, it is clear that there is force of attraction between every two objects in the universe. But what will be the magnitude of this force? What will be the force between two objects of masses m1 and m2 which are separated at a distance r from each other? So in order to evaluate this force, Newton put forward a law which is known as universal law of gravitation. Now students, we will see what is universal law of gravitation. So according to universal law of gravitation, every object in the universe attracts every other object with a force whose magnitude is first proportional to the product of their masses, and second inversely proportional to the square of distance between them. And this force is acting along the line joining the centers of these two objects. It means that according to universal law of gravitation, if there are two objects of different masses, then the force of attraction between them is directly proportional to the product of their masses and inversely proportional to square of distance between them. And this force is acting along the line joining the centers of these two objects. Now students, we will see the derivation of the force by taking two objects A and B of different masses m1 and m2. Now let us see the derivation. So here we have considered two objects A and B of masses m1 and m2 respectively, which are lying at a distance of small r from each other. Now try to understand this figure. Here in this figure you can see that there are two objects, object A of mass m1 and object B of mass m2, and r is the separation between their centers. Now students, the object A experiences a force due to the presence of object B, and this force is FAB. FAB means the force on A due to B. As you can see by arrow, this force is acting on the object A. Similarly, object B also experiences the same force but in opposite direction due to the presence of object A, and this force is FBA. FBA means force on B due to A. As you can see by arrow, this force is acting on B. Now in order to calculate the magnitude of force between these two objects, we will take the two forces FAB and FBA equals to F. Now, as per the law of gravitation, you know that the force between these two objects is directly proportional to product of their masses. As here in this case, the masses are m1 and m2, so we can say the force F is directly proportional to m1 and m2. This is the equation number 1. Again, you know that the force between the object is inversely proportional to square of distance between them, and here the distance between them is small r. Hence, we can say F is proportional to 1 upon r square. This is our equation 2. Now, if we combine these two equations, then we can write F is proportional to m1 m2 divided by r square. And when this proportionality sign is removed, then we get a constant. Hence, we have F is equals to G m1 m2 divided by r square. Here capital G is the proportionality constant and it is called universal gravitational constant. So students, we have the required equation for the force between two objects of masses m1 and m2 which are separated by a distance small r. As per the universal law of gravitation, you know that the force of attraction between two objects of masses m1 and m2 separated by a distance r is given by F equals to capital G into m1 m2 divided by r square. Now, if in this equation we put m1 equals to m2 equals to 1 unit and r1 equals to 1 unit, then we can write F equals to capital G into, in place of m1 into m2 we can write 1 into 1, and in place of r square we can write 1 square. After calculating it, we get F equals to G. So we have the equation F equals to G. From this equation, we can say that the universal gravitational constant capital G is defined as the gravitational attractive force between two objects of unit masses separated by a unit distance. So this is the definition of universal gravitational constant G. But its value remains constant everywhere. That's why it is known as universal gravitational constant. Now we will see what is the SI unit of capital G, that is universal gravitational constant. So the expression for force by universal law of gravitation, we have F equals to capital G m1 into m2 divided by r square. If we rearrange this equation, then what we can write, G is equals to Fr square divided by m1 m2. Hence, with the help of this equation, we can say SI unit of capital G is equals to SI unit of force into square of the SI unit of distance divided by SI unit of m1 into SI unit of m2. Now you know SI unit of force is Newton, SI unit of distance is meter, and SI unit of mass is kilogram. Hence, we can write SI unit of G equals to Newton into meter square divided by kilogram square. Thus, we have SI unit of capital G as Newton meter square per kilogram square. And the numerical value of capital G is 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. This value of G is first determined by Henry Cavendish using a sensitive torsion balance. Now, some important points regarding the gravitational force and universal law of gravitation is that first, gravitational force is always attractive in nature. Second one is that the law of gravitation is universal because it is applicable to all objects whether they are big or small, terrestrial or celestial. Capital G is called universal constant because its value remains same under all conditions. Again, according to the universal law of gravitation, we know that the gravitational force F is inversely proportional to square of distance between the two objects. But what does this relation means? This relation means that if the distance between the two objects is doubled, then the force between them will be decreased by 4 times. And if the distance between the two objects is tripled, then the force between the two objects is decreased by 9 times. And due to this relation, it is generally called inverse square law, because here you can see that the force is inversely proportional to square of distance between them. Hence, it is also known as inverse square law. Now the stability of solar system, motion of moon around the earth, holding of atmosphere around the earth, falling of raindrops, formation of sea tides, all such examples tell the importance of gravitational force. So thank you students. In our next part of video, we will discuss some problems related to the gravitational force. After that, we will discuss Kepler's law. Thank you.